Okay, so here we are with part two. So again, I want to list the possible rational roots here. So we have for the constant, we have plus or minus 1. And then for the leading coefficient, we get plus or minus 1 and plus or minus 3. And those are the only factors of those numbers. So we're going to list that. So now let's list all of our possible p's over q's, or for this part right here, you can say the constants over the leading coefficients. So it becomes plus or minus 1, plus or minus, plus or minus 1, plus or minus 1/3. So those are the only options here. All right, so these are the values that I'm going to try. So let's just go with 1 first. Okay, so let's try 1. And we have 3, 5, 1, and negative 1. So we pull out our 3, we get 3. Pull out our 5, we get, 1 times 3 is 3. So 5 and 3 is 8. Again, multiplying and then adding. 1 times 8 is 8. 1 plus 8 is 9. 1 times 9 is 9. 9 minus 1 is 8. And as you go, sometimes you could see early on that, hey, these numbers aren't going to work. So if you ever get to one that you know isn't going to work, you can stop it before you get to the actual end. So we have 1, negative 1, 1/3, and negative 1/3. Now I know that 1 is not going to work. So I can cross it out. So let's go to negative 1. So with negative 1, again, 3, 5, 1, negative 1. All right, so pull down my 3. And we get, no, I'm going to get this one day. Pull down your 3. Negative 1 times 3 is negative 3. 5 minus 3 is 2. Negative 1 times 2 is negative 2. Negative 2 plus 1 is negative 2. Negative 1, sorry, I can't even add anymore these days. Now, negative 1 and negative 1 is positive 1. And if we look here, negative 1 plus 1 is 0. So we found one of our roots. It's negative 1. Now, one thing you cannot do here is you can't say, oh, I'm going to cross out negative 1 here because I've already used it up. I found out that it's a root. The thing is if you find out that something's a root one time, it could be the root again. So we're not going to cross it out at all. It's only when we find something that's not a root, we know that it's not going to ever be a root again. So here we have 3x squared plus 2x minus 1. So let's try to factor this. So we get 3x and x. And we need this 2 to be positive. So let's try plus 1 and minus 1 here. Let's double check by FOILing to see if this works. 3x and 1 is 3x. Negative 1 and so it's negative 2x. 3x minus 1x is 2x. So that did work. So we get as our other solutions x equals 1/3 and x equals, look, see we got negative 1 as a solution a second time. So my roots here are negative 1, and 1/3. So those would be my roots for this equation. These are my possible roots. Let me take the 1 off here. These are my possible rational roots, but these are my rational roots. So now let's look at a second problem here that's going to be a little bit more involved. So once again, I'm going to start off by listing my possible rational roots. Now this one's going to have several because 12 has several factors. So we're going to have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. All of those are factors of negative 12. And then for 3, we have plus or minus 1 and plus or minus 3. So again, it's the constant over the leading coefficient. So We list our possible rational roots, and this time, again, I'm just going to do the plus or minus and understand that it goes with all of them. So it's 1 over 1, 2 over 1, 3 over 1, 4 over 1, 5, nope, got in the habit of just counting, 6 over 1, and 12 over 1. All right, and now we put those over 3. So 1/3, 2/3, 3/3, 4/3, 6/3, and 12/3. So again, I put all of these constant factors over all of my leading coefficient factors, and this is what I came up with. Now, some of these will reduce out. If we look here, 1/3 is fine, 2/3 is fine, but 3/3 factors to become 1, so that's in there twice. 4/3 is fine, but 6/3 factors to become 2, so we're fine there. And then 12/3 factors to become 4, so we're fine there. So now we're just left with these values here. So if you want to pause the video now and you can work through it. In fact, I recommend that you do that. Okay, now that you've paused the video, let's see what we can get to work here. I'm going to go with 2. Just see what happens with 2. I always like starting with a number like 2 just because 1 typically does not make the numbers any easier, but if you can get 2 to work, 2 is pretty easy to work with. And it also makes your next solutions a little bit easier to work with. So we go with 3, -14, 11, 16, -12. All right, I didn't leave any of them out. Okay, pull down the 3. 2 and 3 is 6. -8, -16, -5, -10, 6, 12, and it worked. Okay, good. So 2 worked. Now I'm not going to cross 2 out because 2 may actually work again. Now there is something you could do here. You could take all of these leading coefficients, put it over all of these leading coefficients, and you would see that 4 would go away, 12 would go away. So you get rid of some of these, but I'm not really going to worry with doing that right now. Let's go with trying 1. We can't turn this into a quadratic yet because we still have 4 terms. Remember, we start off with a quartic, so now we've worked it down to a cubic. When I find my next root, I'll have a quadratic, and then I can factor it. So we get, and I don't divide back into the original problem. I divide back into my reduced problem because if 2 is a root in there more than one time, it would not show up. So I need to use my reduced one, which is good because it's easier to work with typically. Let's go with 1 and see what happens with 1. All right, so I've got 3. 1 and 3 is 5. What in the world? I'm getting ahead of myself. 1 and 3 is 3, -8, and 3 is -5. That's -5. All right, -5 and -5 is -10. And, okay, that's not going to work. So now I can cross out negative. I can cross out +1 because it does not work. Let's go with a -1 and see if it works. I'll just erase the bottom 2 rows here. All right, so 3, -1 and 3 is -3. -8 and -3 is -11. That's going to be +11. 11 minus 5 is 6. -1 and 6 is okay, so we got a next root. So the next root is -1. And the good news is I'm down to a quadratic here. So let's look at factoring this quadratic. It's 3x squared minus 11x plus 6. So I've got 3 and 1. Now I can't put 3 right here or 6 right here because it shares a common root here. So I'm going to have to put negative 2 and negative 3 here and see what happens. Okay, 3 times negative 3 is negative 9. Negative 2 and x is negative 2. So negative 9 and negative 2 gives me the negative 11 that I need. So I end up with x equals 2/3 and x equals positive 3. So my solutions here are negative 1, 2, 2/3, and 3. So that gives me my solution. So this section does take a good bit of time. So please allot for a good bit of time. Again, this will be due April the 7th, but I will move the unit review over to where it's due around April 17th.